Alright, we're going to be talking about relations and functions today. Our objective today is to determine whether a relation is a function and define the domain or range and use function notation. A relation is a pair of numbers of one set called the domain with another set of numbers called the range. The set of ordered pairs x, y. The domain is a set of x values and the range is your set of y values. The pairing of two quantities as ordered pairs is called a relation. Mr. Zumo brings some of his students to a museum. The admission fee is $7 per adult and $3.50 per student. He plans to bring 10 students. What is his total cost? We can model this situation by the equation of y equals $3.50 x plus 7. We set this up where y represents the total cost. The rate is $3.50 per student, right? So $3.50 times x, which x represents the number of students, and then plus 7, our constant. The $7 is the $7 fee for me to bring you to the museum. We want to know what the cost is for 10 students. We would substitute 10 in for x. It would be our input. Okay, that would be one of the numbers in our domain. 10 times $3.50 is $35, and $35 plus a $7 fee for myself is $42 total. $42 is the output, or your range number. Okay, it's one of the numbers in the range. It matches up with the 10, because for 10 students, it will cost $42. As we substitute different numbers in for x, we'll get different numbers for y. There's a relation between the number of students and the total admission fee. The number of students determines how much the total admission will be. The number of students is called the independent variable, or the input. We're substituting a number into x. Okay, that's why it's the independent variable, the input. The total admission fee is called the dependent variable, or the output. Y depends on what you substitute in for x to recognize its total. So that's why it's the output. The output is dependent because it depends on what the input is in order to find it out. We'd have the coordinate point of 10, 42. You can identify functions using mapping diagrams. For this problem, they're asking you to identify the domain and range of a relation and represent the relationship with a mapping diagram. And is this relation a function? Okay, so we have these ordered pairs. Basically, the problem would look something like this. I would ask you this question and just give you the coordinate points. It would be up to you to do the rest of this. The domain is -2, 0, 4, and 5. We get those numbers from all of the x values. As you can see, -2, 0, 4, and 5. The range is all the y values. 1/2, 2.5, 6.5, 2.5. Notice, when we write the numbers that are in the domain and the range, we write them from least to greatest, and we write them only once, even if they occur more than once. As you can see, this 2.5 occurs more than once. We still only write it once when we write it in the range. All right, let's look at how to make a mapping diagram. You're going to make two ovals. Okay? The left side will represent your domain. The right side will represent your range. You then write your numbers again from least to greatest, and only once. So -2, 0, 4, and 5. 1/2, 2.5, 6.5. As you can see, right here is the finished product of what we're starting over here. The only difference from right here to here is that we have lines drawn in the original mapping diagram that's already listed. Where did those lines come from? Well, they come from our ordered pairs. Okay? As you can see, -2 matches up with 1/2. So I draw a line from -2 to 1/2. 0 matches up with 2.5. So I draw a line from 0 to 2.5. 4 matches up with 6.5. So I draw a line from 4 to 6.5. And 5 matches up with 2.5. So I draw a line from 5 to 2.5. That is how we create our mapping diagram. All right, this relation is going to be a function, but we're going to talk about y in a little bit. Right now, we're still going to just focus on how to make a mapping diagram. Again, when making a mapping diagram, it is important to list the numbers in least to greatest order and to only write each number once. even if it occurs more than once. If there are words or letters, you should again only write them once and list them in alphabetical order. Let's check out one more example problem. Here we have the coordinates of 6, 5, 4, 3, 6, 4, and 5, 8. Alright, so we're going to make our mapping diagram. Our domain numbers are 6, 4, 6, and 5. So when we list them, we list it as 4, 5, 6. Again, least to greatest, only once. Our range numbers are 5, 3, 4, and 8. We're going to write those in least to greatest and only once. 3, 4, 5, 8 is our range. To make our mapping diagram, we have our domain numbers on the left. We have our range numbers on the right. We write them in the same orders. 4, 5, 6 for the domain, 3, 4, 5, 8 for the range. And then it's just a matter of matching up the coordinates. 6 went to 5, so I draw a line from 6 to 5. 4 went to 3, so I draw a line from 4 to 3. 6 goes also to 4, so I draw a line from 6 to 4. And 5 matched up with 8, so I draw a line from 5 to 8. This is our mapping diagram. From here, we can do more things with the mapping diagram. We can identify types of relationships and if it represents a function or not. There are types of relationships, 4 to be exact. 1 to 1, 1 to many, many to 1, and many to many. We're going to tie this to dating right now, okay? When you think of dating, you can help recognize if this is a function or not, based on the relationship you have. For the first one, 1 to 1. We're going to pretend that you are on the right side, and the person you're interested in is on the left side for all of these relationships. In a 1-to-1 relationship, it's a functioning relationship. It's happy because the person you like likes you. In a 1-to-many relationship, again, you are on this side. That situation means that one person that you like likes you and other people. They like multiple people. That's not a happy relationship to be in. That would not represent a function. In a many-to-one relationship, not as ideal as 1-to-1, but it's still a functional relationship. Because here, this means that many people like you. And lastly, the most true relationship in middle school, this would not be a function. This is a many-to-many situation. This means that everyone likes everyone. Many people are liking many people, okay, on both sides. So it's a very difficult situation. We have multiple inputs matching up with multiple outputs. This would not be a function. The other way to remember this is, if the second word is 1, it's going to be a function. If the second word is many, it's not going to be a function. For a relationship to be a function, each input can only have one output. Okay, so if an input has more than one output, it's not going to be a function. Which is why when we see the word many as the secondary word, it's going to be the not function situation. Let's look at this based off a mapping diagram. Mapping diagrams are often used to show relationships. This is a 1-to-1 relationship. Each input is mapped only to exactly one output. This is a happy functioning relationship. This is a 1-to-many relationship. Each input is mapped onto many outputs. As we can see, A is going to 60, 61, and 62. Even though B is only going to 63, as soon as we see the word many, it beats out the word 1. Okay? It trumps it. So, when we see this, we have to recognize that many beats the word 1. Okay? Many-to-one situation here. Many inputs are mapped onto one output. This is the opposite of the last situation. Here we had A going to many things. Here we have A and B going to many things. So as soon as we see that multiple things are going to one thing, the many beat out the 1. Okay, so even though C is going to 70 and that's 1-to-1, as soon as there's a many situation, it beats out the word 1. So this is a many-to-one situation. And lastly, we have a many-to-many situation. A many-to-many situation is essentially if we have a 1-to-many and a many-to-one within the same mapping diagram. As you can see, we have A going to 60 and 61. That's a one-to-many situation. But B and C are going to 62. That's a many-to-one. When we see many-to-one and one-to-many, the many, again, beats out the word one, and it's a many-to-many situation. This would be not a function. You can also identify functions using a vertical line test. When we plot points, all these points can only go through one vertical line at a time. So, if I draw this a vertical line, when I move this vertical line, sometimes called the pencil test, notice I'm only touching one coordinate point, I'm touching one coordinate point, I'm touching one coordinate point, I'm touching one coordinate point. This would be a function. Below, we're only touching one coordinate point in this parabola at any time. It would be a function. Let's say I rotated it. Let's say we had this graph. This would not be a function. And let's look at why. Touching one point. But for the rest of this time, I'm touching 2 points on the vertical line at any time. Right here and right here. As soon as you're touching more than 1 point, it's not a function. That means that when we have an input, we have multiple outputs. So if we move this away for a second, at x being 2, we have a little bit over 1, so this would be like 2 and 2/10, let's just say. So we'd have 2 comma 2 and 2/10, and we'd have 2 comma negative 1.5, about roughly, let's just say. All right, that's not possible. Each input can only have one output. Therefore, this is not a graph.